Hello and welcome back. In this part of the course, we'll switch gears and focus on simulation. We'll start chapter 24. There is a mini exercise associated with this video that hopefully won't be too troublesome. So let's get into it. So chapter 24 gives us the building blocks to generate random numbers, and then we'll really apply those to finance in the next chapter. Hopefully you'll see how simulation fits into financial analysis better after we go through this part of the course. There's some areas where using simulated data is better than using actual data, and then there's some limitations of simulated data. We'll learn how to simulate things that are relevant to finance. There's lots of software packages that will just do it for you, sort of like a black box interface where you plug in some numbers and then the output gets automatically spit out. I think it's much better for purposes of learning Excel to build it from scratch, and then you'll also are more likely to understand what's going on, with the work that you're doing if you build it from scratch. So our main sort of input into the simulation exercise is actually the RAND function. It's a function that takes no arguments and it generates some number somewhere between 0 and 1. And let's use the RAND function to simulate a coin toss. It's a good first simulation exercise. Got a spreadsheet associated with today's video that we'll spend some time on under in-class exercises. It's the April 16th simulation spreadsheet. So let's take a look at that. Here on the coin toss and die roll tab of the spreadsheet, we've got some spreadsheet architecture that maybe merits some comments. Usually in all my simulations, I like to have a first column that shows the number of the simulation. So each of these rows will be one simulated coin toss in a little bit. And I usually like to number those 1, 2, 3, and so on. We'll simulate 100 coin tosses. I want to show you an easy way to number a column, because we'll be doing it quite a lot, and it's possible that you'll have numbered columns that have like really long series of thousands of simulations. So what you do is you start by numbering the first row as 1, and then put the cursor on that. And then under the Home tab, you see this option Fill, and then Series. We want to make a series. And then we want the series to be in a column, so we put we select columns, the radio button. Step value is 1. Increase the number by 1 for each step, and then we number it from 1 to 100, going by 1. And if you do that and click OK, we'll have a column that's numbered from 1 to 100. That keeps track of our simulations, right? And like I said, we'll use the RAND function to simulate a coin toss. So the RAND function takes no arguments at all, equals RAND. And then if I hit enter, it'll be some random number between 0 and 1, right? And with the RAND function, if you do something else in the spreadsheet, you'll see that the RAND function updates itself automatically to a new random number. If you want to update it another way, you can hit F9. Which is more, if you just sit here doing this all day, it's a little bit more exciting than watching paint dry. I could do that for a little while. But let's use the RAND function to simulate a coin toss, right? And so the way I would do it is, if you flip a coin, about 50% of the time you'll get heads, 50% of the time you'll get tails, right? So we could code it such that if the RAND function comes out to be greater than 0.5, like it is here, let's call that a heads, right? And then if a RAND function is less than 0.5, like it is here, we'll call that tails. So I'll say, based on, suppose I'll use the if statement and and just make a cell reference to the RAND function first. So if this is greater than 0.5, that'll be a heads. And why don't we code a heads as 1, right? So if the RAND function returns a value of greater than 0.5, we'll call that 1. A heads is equal to 1. And then if the RAND function return is less than 0.5, we'll call that tails, right? So here, this corresponds to a tails, right? Here's a heads, and so on. So let me build this into just one cell, right? One formula. So equals if, instead of a cell reference to the RAND function, equals if the RAND function is greater than 0.5, call that a heads, otherwise call that tails. Great. And so, one individual coin toss is fine. But if we copy and paste this down throughout the whole 100 simulations, if I select this column, I got 47 heads, right? Because the sum of this column is 47, so there's 47 of these, ones in this column. So 47 heads. You hit F9, you'll get a different result, right? So good first simulation. Let's do another simulation exercise, and I want to show you some tools to analyze simulated results, right? So the important thing with simulation is you get a range of possible outcomes. That's one of the best parts of simulation, actually. So let's simulate a die roll. There's a rand between function, which also simulates another uniform distribution, a discrete uniform distribution, where if we say rand between, there's two arguments. The lower end, we'll say 1, and then the upper end, if it's a 6-sided die, normal 6-sided die, if we simulate something between 1 and 6, this is like simulating a regular old 6-sided die roll, right? I got a 4 in my first roll. Let me copy and paste that down. And you can see we get 100 simulations of a die roll. And actually, just for illustrative purposes, I'll simulate another die roll with the exact same formula, right? Rand between 1 and 6. Copy and paste that down. And then the sum of these two dice, if we add up 2 dice, now we've simulated 2 die rolls, right? Simulate the rolling of a pair of dice. Look at us go with our simulation. And you can see here's the sum of the dice. And then I do this because I want to show you how a convenient way to report the results of this simulation, right? Here, what I've got is all the possible outcomes for the rolling of 2 dice, right? 2 through 12. And then I've written 12 as more than 11. You'll see why in a little bit. So what I want to do is count the frequency of each of these die rolls, right? How many 3s are in this sample of 100 simulated die rolls? How many 5s? How many 7s? How many 9s? And so on. And to do that, there's a frequency function, right? And so let me show you how it works, right? So what you do is you select, if I've got, let's see, equals, let's show the syntax of the function first, right? So the first argument is the data, that'll be this. And then the second argument is the range of possible outcomes, or is a range of possible outcomes. And let me show you how it works. So first I'll select all of these, this whole range of cells and say equals frequency. Oh, by the way, it's an array formula, right? So we can select multiple cells and have this frequency formula operate across a range of cells. So equals frequency. First argument is the data, right? Our simulated die rolls. And then the second argument is the bins, right? And so that's some range of possible outcomes. So if I give it this, I'll give Excel this range of bins. And notice how the range of the bins is 1 smaller than the range, than the output of the function that I've selected, right? So what this will do is we'll count up all the 2s in the data, all the 3s and 4s and so on, and return how many simulations came out with each of those rolls, right? And then this last one that's not associated with the bin will be how many points in the data came out greater than the highest bin. So let's hit Control-Shift-Enter and see what comes out, right? So there were 2 2s in my sample, 10 3s, 6 4s, and so on, right? In 2 cases where we rolled a 12. And then, like I said, if you hit F9 or do something else in the spreadsheet, it will, the randomly simulated results will update themselves. So the frequency function is a good way to summarize data if we've got a range of outcomes that we want to report the frequencies for. And then just notice how the syntax is interesting, because the range of the output for the function is 1 larger than the range of the bins, isn't it? So the mini exercise, you're responsible for rolling 3 dice. I would do 100 simulations. You can fill down, might be good practice to simulate or to create the column of 100 simulations, do 3 calls of the RAND between function, right? And then sum the dice, and then see if you can use the frequency function and set up the bins correctly. So the sum of 3 dice won't be, some number between 2 and 12, right? It'll be some number between 3 and 18, okay? So use the frequency function to see how often, just like we did with 2 dice, and then report how many times you rolled 4s across the 100 simulations of 3 die rolls, right? And then report how many times out of 100 the sum of the dice was 9. So basic simulation exercise, and it'll get you comfortable with using the frequency function and the RAND between function. So thanks for tuning in, and we'll see you in the next video.